Hi, welcome to our math. Today I'm doing a series of videos on rational functions and their graphs. All right, this says find all the vertical and horizontal asymptotes for the following function, list any holes, then graph. All right, so when I do a rational function, I always start with the denominator. I always start with saying this is where we find the vertical asymptotes. So I say x squared minus 9 is x plus 3, x minus 3. So if I do that, x minus 3 over x plus 3, x minus 3, I'm going to notice that those reduce because x minus 3 divided by x minus 3 is 1, and I'm left with 1 over x plus 3. This is what I'm going to end up graphing. When this reduces out, then what I have is x equaling negative 3 is an asymptote, and x equaling 3 is a whole. So to figure out the full whole, I'd say f of 3, using my reduced, is 1 over 3 plus 3 equals 1/6. So 3 1/6 is my whole. So right about here is a hole in the graph. So this is the difference between an asymptote and a hole in the graph. I can put in my vertical asymptote at negative 3. That's right about here. I always put it in as a dotted line. It's my little barrier. X equals negative 3. Okay, as for horizontal, asymptotes, the way we test for those is we look at the dimension of the numerator polynomial, numerator of x, versus the dimension of the denominator. The dimension of the numerator is 1, the dimension of the denominator is 2, so the numerator is less than the denominator. In that case, y equals 0 is a horizontal asymptote. So I can put that in. The rules are if the denominator is bigger, y equals 0. If they're the same, then you divide and it's the coefficient. And if the numerator is bigger, there isn't a horizontal asymptote, but there could be a slant asymptote. But that's for a different video. Okay, the next thing I do is I come up with points to graph. Coming up with points to graph can be tricky. Well, no, it can be tedious. So I have x and f of x. I always look for left and right of my asymptote. So I would probably go from, say, negative 5 to, I would probably go negative 5 to 5 because I don't really need left and right of the whole. I can just skip over the whole. So I'd probably go negative 5 to maybe 0. Yeah, so negative 5, negative 4, negative 3, negative 2. I need the whole graph on here though. So if we come to here, we're probably good. Negative 1, 0. And I need to plug each of these into that function. Now, some of you have calculators that, like if you hit mode and table, you could come in here and say alpha x minus 3 divided by parenthesis alpha x squared minus 9, and then say, hey, I want to start at negative 5. I want to go to 0, and I want the step to be 1. You can also go 0.5, and it gives you your asymptote right there. But then I can just come in and say, hey, negative 0.5, negative 1, 1.5, 0.3 repeat. Where did I miss one? This one's 0.3 repeat. How did I mess up following my calculator? -2 is 1. Oh, it's because I put in 3. I usually skip my asymptote. Okay. Skip your asymptote. No. So then I can come in and say -5 is 0.5 and -4 is 1. And I don't have all of the points. You could put in some of the half points if you want, but the idea of an asymptote is the graph approaches without crossing. And this gives me enough to know what's going on, except those should be negative if I follow the rules. All right, -5 is -0.5, -4 is -1. Sorry about that. Don't miss your negatives. -2 is 1. -1 is 0.5. 0 is 0.3. This is coming up. This is coming down. And I'm going to come all the way to my hole, skip the hole, and go on. And I've now graphed it, and I've sketched it. And I like using the table on my calculator to help generate these values. It makes it so much easier. So much easier. All right. I hope you've enjoyed this video. Please subscribe to my YouTube channel. And I'll see you on the next video. Thanks.